Hello and good morning. CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this morning's video tutorial is going to be on challenge activity number 5, where we're going to be taking a look at configuring OSPF. Again, highly encourage you to avoid the answer key until after you've gone through the configuration section. Simply work with your scenario and your job aids to try to work your way through this activity. So if we take a look at the scenario here, you can see the customer expects that you're going to implement OSPF according to their network topology. You can see the topology over on the right-hand side. Before you start the configuration, you're told that the customer also wants you to harden OSPF on the HQ1 router by configuring passive interfaces. And so what they're saying there is that they want to make sure that on that HQ1 router that the OSPF process is not sending hello packets out interfaces on which we're not trying to establish an OSPF adjacency. All right, we also need to make sure that the router dist down here at the bottom does not actively participate in the OSPF elections on broadcast segments. So in other words, this Ethernet 00 and 01, that screams IP OSPF priority. And if it's not going to participate, do we set it to 255 or do we set it to 0? Exactly. We would be looking at setting it to 0. All right, so we're going to do, and again, remember, we're talking about IGP, internal gateway protocol. So we're going to set that up here internally, which means we would not be running OSPF between the gateway router here and the internet, and likely not sending out, we would passive all of those interfaces there, the loopbacks, representing quote-unquote external networks. All right, so let's go ahead and dive in, and we'll start from a top-down approach here. So let's come on to the gateway router, and we're going to go from user exec to privilege exec, and let's say show IP interface brief and see which networks we have configured here. Well, remember that Ethernet 01 interface, that 209.165, that publicly routable IP address, we're not going to be running OSPF on that interface because we're not going to be peering with our internet service provider with OSPF. Again, in a couple of weeks, we're going to get into our conversation on BGP, the Border Gateway Protocol, and that's where we're going to start our deep dive look into how you would interface with a dynamic routing protocol with a provider, but using BGP. All right, so the two interfaces we're interested in right now are going to be Ethernet 00 and the loopback interface. And so let me think about this for a second here. We're going to go ahead and start up OSPF on, let's see, do show run. Do we have anything set up yet? Do show run section OSPF. So we don't have anything. So let's go ahead and say router OSPF, and we'll just use process ID 1. So I'm going to say passive interface default. I'm going to set the router ID to 1.1.1.1, and I'll increment it as we go down. So we'll set the router ID to 1.1.1.1, and then I'm going to say no passive interface on Ethernet 00, and that's my 172.16. I'm going to leave that loopback interface passive because, again, we are not establishing an adjacency with a loopback interface. All right, so let's go ahead and get into interface Ethernet 00. We're going to say IP OSPF1 area 0, and it looks like we're going to use one huge area. And so in terms of kicking OSPF off here, we've actually done our job, right? So let's take a look at our OSPF section. Do show run section OSPF. All right, and that is what it looks like right now. We've got our router OSPF1, the router ID passive interface default, and then no passive interface on that Ethernet 00 interface. So the gateway router looks pretty good. So now let's go ahead and transition down to let's do HQ1. Oh, I get in that situation where HQ1, I want to use 1.1.1.1 for the router ID and 2.2.2 here. So let's change the router ID on the gateway router. I'm going to change it to, let's just say 9.9.9.9, or not routing, sorry, router ID. And we have to get into the router OSPF1 to set that. So we're going to say 9.9.9.9. There we go. All right, now let's get onto the HQ router. and let's get things configured. Remember, they wanted us to harden the HQ router, but we're going to harden all of these routers basically with that sort of passive interface command. And typically when you hear the phrase harden a router, we're talking about setting up some kind of MD5 authentication between the routers and things like that, that's truly hardening the router. The passive interface, that's more like due diligence is sort of how I look at it. All right, so let's say show IP interface brief. And again, you can see we've got 3 total interfaces here. So let's get into global config. We're going to say router OSPF1. I'm going to set my router ID on HQ1 to 1.1.1.1. We're going to say passive interface default. And now I'm going to jump into the interface Ethernet 00. We're going to say IP OSPF1 area 0. And I'm going to get into interface Ethernet 01 and say IP OSPF1 area 0. And then we're going to jump into the loopback interface. And you know what? I just realized, did we not configure do show IP OSPF interface? And let's see, did I get the loopback interface? I don't believe I did. Interface loopback 0, IP OSPF1 area 0. And actually do show IP protocols. So we're going to say show IP protocols. And okay, good. So we're set up there, and then let me say, whoops. There we go. Okay, we see the loopback and we see the Ethernet interface, so we're good here. So back over to HQ1, interface loopback 0, and IP OSPF1 area 0. Now we want to make sure, I think it was the dist router is not going to be running. And let me take a look here real quick at the job aids. I believe we've got multiple areas, and we do. So I'm going to need to change Ethernet 01 is going to be in area 1. All right, good enough. So Ethernet 01, and we'll get back into interface Ethernet 01, is going to be IP OSPF 1 area 1. And so we've got that set up there. We should see, do show IP OSPF neighbor. Do we have any adjacencies yet? We do not. Let's check over here real quick. Do show run interface Ethernet 01. Do show run interface Ethernet 00. IP OSPF 1 area 0. And that interface is up. Do show IP interface brief. So we should have an adjacency coming up here on this Ethernet 01 segment right here with the gateway router. And did I not say that's what it is? Do you see what it is? Do show run section OSPF. Whoops. Yeah, so we passive interface default, but what did I not do? Router OSPF1. How about no passive interface? And before I say that, actually it's right above here. I'm looking for Ethernet 00 and 01. So no passive interface Ethernet 00, no passive interface Ethernet 01, and now we should see that adjacency should be established here. There we go. Between neighbor, and that's the router ID of the gateway router, and we've gone from loading to full. So if I were to now say do show IP route OSPF, you can see that we're learning that loopback address, the 192.168.3.3, which is the loopback address here of the gateway router. All right, so we've taken care of the HQ router, or HQ1 router, I should say. So now let's go ahead and let's move over to HQ2, and let's make sure we get our areas right here. We've got all kinds of stuff going on. So Ethernet 01 is area 1, Ethernet 02 is area 2, and then Ethernet 00 is going to be area 0. So a lot going on here on HQ2. So let's go ahead and get into privilege exec and say show IP interface brief. And there are the interfaces we're going to be working with. So let's get into global config. We're going to say router OSPF 1. We're going to say passive interface default. We're going to say no passive interface. Let's get that right this time. Ethernet 00, 01, and 02. And we'll leave the loopback passive. So at this point, we're We're going to set our router ID to 2.2.2.2, and now all I need to do is go into each of the interfaces, Ethernet 00, and say IP OSPF1 area 0, keeping in mind that we've got 3 areas on this router. Interface Ethernet 01 is going to be area 1. Ethernet 02 is going to be area 2, and you can see the adjacencies are coming up as we move along here. And then we're going to go into interface loopback 0, and loopback 0 is in area 0, I believe. Let me double check that real quick. We come up here, whoops. And yes, the loopback 192.168.2.2 is in fact in area 0. So now if I were to go back to the gateway router, let's take a look here. On the gateway router, if I were to say do show IP route OSPF, let's see what we see. We should see some intra-area routing information, and we should also see some inter-area routing information. And we do. The OIAs are the inter-area routes, and we see those. And we also see the intra-area routes, which are the loopbacks on the gateway router, on the HQ1 router and the HQ2 router. All right, so we've taken care of the gateway, HQ1, HQ2. Now let's come down to the distribution router. And we're going to go from user exec to privilege exec in the global config. Do show IP interface brief. Let's see what we're working with here. So Ethernet 00 and Ethernet 01, and we also have a loopback address. And let me confirm with the job aid here, real quickly, that the distribution router, you can see everything is area 1. All of the links and everything is area 1 here on the distribution router. So, excuse me. So let's go ahead and jump in. Let's get into that router. OSPF1, passive interface default, no passive interface Ethernet 00, no passive interface Ethernet 01, and let's set the router ID here to 3.3.3.3. Now, remember, the one thing that we needed to do on the distribution router is we need to make sure that it does not participate in the DR-BDR election. So before we do that, let's get into interface Ethernet 00 and say IP OSPF, OSPF1 area 1, interface Ethernet 01, IP OSPF1 area 1, and then we're going to get into interface loopback 0 and say IP OSPF1 area 1. And you can see that those adjacencies are coming up. What we also want to do is interface Ethernet 00 and say IP OSPF priority priority 0 on the Ethernet interfaces. Now, this is going to ensure that we do not participate excuse me, in the DR-BDR election process. All right, so that is going to take care of the distribution router. Finally, we've got the branch router. I got quite a few routers to configure here. So we hit on the branch router, and let's go from user exec to privilege exec and say show IP interface brief. And as you can see, we have quite a few interfaces here, loopbacks 0 through 4, and these are simulating our external networks. We're going to have a single adjacency here over Ethernet 00, and let's take a look at the job aid real quick and see everybody is going to be in area 2. And again, we've got these external networks, so those loopbacks, I'm going to check to see if those are being redistributed. I'm not sure if they're redistributing those in or not, or if they're just going to be configured here as external networks. So again, we're area 2 on our single neighbor adjacency link here, this Ethernet 00 interface, and we've got our loopback here as router 5. So let's get into global config. Whoops, sorry about that. So let's go ahead and on the branch router, jump into global config, and we're going to say router OSPF 1, passive interface default, excuse me, and then no passive interface Ethernet 00. Let's set our router ID to 4.4.4.4. All right, and then we're going to get into interface Ethernet 00, and we're going to say IP OSPF1 area 2. And then let's do the same thing on our loopback 0 anyway, the 192, and say IP OSPF1 area 2. All right. Excuse me. So that takes care of the branch router. If I were to say do show IP route OSPF, what would it look like? Well, it would look just like that. Remember, we're area 2 here as the branch router. So everything that we're going to be receiving, the majority of that information is going to be coming from another area, either the backbone area, or when the backbone area injects those type 3 LSAs into area 2, we're going to be getting that inter-area OSPF information that's coming out of area 1. And again, if I were to say do show IP OSPF database, you can see that we have our type 1 LSAs, right? The router link states. So here are the type 1 LSAs for each of the 2 routers in area 2. You can see that we have a DR BDR election that takes place, because what is the link ID value for the type 2 network LSA? Exactly, it's the IP address of the router who is the DR. And we can see that the advertising router is 2.2.2.2, so we know that HQ2 is currently the DR. We can also check that if I were to say do show IP OSPF neighbor, do show IP OSPF neighbor, you can see that router 2, how do we see that router? What is our state with that router? Full, and that router is the DR. And it has a priority of 1, which is our default priority. And then we see our type 3 information, right? All of these summary link states that are coming in to our network. All right, so now what we're going to do, since we've already hardened router 1 and we've already done the priority, actually for this challenge, this is where things wrap up. But let's continue the conversation a little bit and let's tweak some things. So this branch router right here, does it need all of the type 3 LSAs that are going to be sent in from HQ2 into area 2? Is all of that information needed, or is any of that information needed? So remember, branch has a single exit point out of area 2, right? And this is area 2. So what could we do over here that is probably going to make sense, that's even taking things a step further, probably a smart thing to do, is the branch router doesn't need all that more specific information. What is the only thing the branch router with a single exit point out of off its segment, what is the only thing that it needs? The only thing it needs is a default route. So if I were to come here to the area border router, HQ2, and it's an area border router because, again, it meets the definition of an ABR. It has one interface in the backbone area, area 0, and one or more interfaces in other areas. So if I were to say router OSPF, what do we say, 1. Do show run section, let's make sure here, OSPF. I think I used 1 everywhere. We did. All right. So how would I turn this into a stub? And we'll walk through it. I'm going to do a stub first, and let's see what effect that has. Does it get rid of all that type 3 LSA information that we are no longer going to need? So if I was to say area 2 and stub and hit enter, right? Now the adjacency is going to go down. And why is that? Remember that the stub flags, how are those stub flags being communicated? Whether I'm a stub, I'm a totally stub, I'm a not so stubby area, or I'm a totally stub, not so stubby area, which is also referred to sometimes as a not so stubby area total stub, right? So there's 2 ways that you can say it. And remember, if totally is in the name, that is a Cisco secret sauce, right? That's that Cisco awesomeness where they decided to go ahead and extend the RFC compliant stub areas, which are just simply stub and NSSA. Those are your RFC compliant stubs. And then Cisco looked at those and said, well, hold on a second. If you're going to make it a stub, why not make it totally stub? So let's talk about the difference between those 2. So the first thing we need to address is we're down, right? We don't have a neighbor adjacency. Do show IP OSPF neighbors. We don't have an adjacency. You can see we're down here, druther, with the router ID of 4.4.4.4. We know that's the branch, right? And so it is down. So in order to bring that up, in the hello packets, that is where those stub flags are being communicated. And it's critical that we match the flags. So down on the branch router, if I come down here, we're going to say router OSPF, router OSPF1. And if I spell router correctly here, router OSPF1, I'm going to say area 2 stub. So now on both sides, it says area 2 stub. And what that's going to do is the hello packets are going to go back and forth, and we're going to agree, and now we're going to go from down, right? We transition through either the attempt or the init states, right? We go to the two-way, we go to the EX start, the exchange, loading, and full. So now we're back to full. So now when I say do show IP OSPF neighbor, what do we see? Exactly. We see that the adjacency is back, and now we are a stub. So if I were to say do show IP route OSPF, you can see that as a stub, we auto-magically receive the default route. But did this solve the challenge that we were working with? And that challenge, remember, is do I need all of that more specific routing information, or do I just need a default route? Well, we've established that we only need a default route. And so now we go back to the conversation of we had a regular non-stub OSPF area 2. We decided that since there's only a single ingress and egress point out of that network, out of area 2 for the branch router, that we're going to make it a stub because we don't need a bunch of more specific information. We only need a default route. So we turned it into a stub. But what we see with a stub is that there's no type 4s, no type 5s, and no type 7s allowed. We have no external information here. There's no ASBR information by definition, right? If I don't have any type 5s, then I don't need any type 4s because the type 4, remember, it's like that guy on the corner with the big arrow trying to get you to go to the furniture store, the carpet store, the mattress store, whatever the case may be, right? And he's spinning that arrow. He's your type 4 saying, hey, here's how you can get to the ASBR that's responsible for this external information. Well, in a stub, we can't have that. And let me prove that to you right now. So we have all these loopbacks, right? So what if I were to say, on the branch router here, redistribute connected. So actually, redistribute connected subnets. I always get burned by that subnets argument. So even when I say redistribute connected subnets, take a look. OSPF ASBR without, so I'm trying to turn the branch router into an ASBR because it's going to be originating external information. No can do. I can't do that here, right? That's not going to work. Excuse me. So this is proof that we can't do type 5s, we can't do type 4s because we can't have a 4 if we don't have a 5, and it's not an NSSA. It's just simply a stub. So we're not going to have type 7s because it's not an NSSA stub type, right? So what do we get? We get 3s, we can have 2s, and we can have 1s in the stub area. And we auto-magically, and let me actually make sure I get those two commands pulled off, do show run section OSPF, and we're going to say no redistribute connected subnets. Let's make sure that's out of there. And yeah, so it's funny, you say no redistribute connected subnets, but it leaves redistribute connected in there. So no redistribute connected. All right, so now we should be back to being a valid configuration here. Because again, no type 5s, which means we're not going to have 4s, and no 7s because we're not an NSSA area type. So that's the stub area, but again, it doesn't solve do show IP route. Whoops, do show IP route. It doesn't solve the problem that we still are receiving all of this more specific type 3 information in addition to the default route. I only need the default route. So what do we need to do? Exactly. We need to make it totally stub. And remember, totally stub, Cisco's secret sauce. Engineers at Cisco said, yeah, the stub is great, right? you dump that default route in there. However, if there's only one way out and you're going to make it a stub, why not get rid of all of that type 3 LSA information? So let's make it so that you only get type 1, type 2, and a single type 3, which is going to be the default route. So how do we do that? We're simply going to change our stub setting here, and let's get back to area 2 stub. And if I do a question mark, you can see no summary. And that's going to turn it into a totally stub area. Now, remember, it's the ABR, the area border router, which is HQ2, that's responsible for injecting the type 3 information into area 2. So it's only on the HQ2 ABR that I need to say no summary. Down here on the branch, I can simply leave it as area 2 stub. And that is going to work because it's on the ABR with that Cisco special totally stub setting that we're going to go ahead and filter out all of the OSPF type 3 information and only have an OIA, a single type 3 LSA, which is the default route. That is all we need. That's it. So that's your stub area. That's your totally stub area. Now let's say, okay, well that's great, but I need to inject these external networks. So you can see we've got this big cloud over here, external networks connected to the branch router. I need to make sure that these get advertised so that the HQ, the gateway, the HQ2, and the dist, they know how to get to these external networks. So if we were to look on the branch router right now and say, do show IP interface brief, and let's take this guy here, 172.31.64.1. So if I was to come up to the gateway router and say, show IP route for 172.16.31.1, you can see the subnet's not in, I don't have a route. What about the forwarding table? Show IP route. Do we have a default route? Or show IPsef, sorry. Do we have a default route to the 172.16.31.1? I've got quad zeros, right? No route. So if I were to say show IP route, gateway of last resort is not set. I have no way to get there. So when I say ping 172.16.31.1, and let me double check to make sure that's the right address. 172, oh, it's 172.31.64. 172, and actually now we got to rerun those commands. So show IP route, and actually you can see, do we have a route here to the 172.31? We don't. And we're not going to have a forwarding entry either because we don't have a default gateway. So if I were to kick a ping off to the 172.31. And I don't know why I can't remember these addresses, 64.1. 172.31.64.1. What's going to happen? Am I going to have any reachability to those external networks? Let's say that the routers in my OSPF domain need to get to those external networks. And let's go ahead and kick off a repeat 100,000, right? So that's definitely going to run for us. So now the question becomes, okay, I did a stub area, right? First we set it up as a stub. But remember, the stub says, okay, we're going to have type 1s, type 2s, and all type 3s. So then I said, I don't want all type 3s. I'll just take the default. So then we said we're going to make it a totally stub. And the totally stub says you're going to have only type 1s, only type 2s, and a little asterisk next to the type 3, that default route. But now I've got these external networks, right? And so here's the use case, right? We were walking through each of the stub network type use cases. So I'm perfectly fine here in area 2 as either a stub or a totally stub. It all depends on, do I want to see all the more specific type 3s or do I just want that default type 3? But now your boss comes to you and he says, hey, all of this external information from these external networks, these guys need to be able to hit those networks. So let's make that happen. You go and you say, create your route map with a prefix list, and you go to redistribute, and you find out that it's not going to let you do it because it's a stub or a totally stub. There are no in both of these guys. no type 4s, 5s, or 7s allowed, which means no external information. So how do I get external information in here? And again, keeping in mind that when we get that external information into Area 2, the only way we can do that and to keep it as a stub network type, it's going to show up as a type 7, we need to make it an NSSA, a not so stubby area. And the not so stubby area says, well, we'll have type 1s and we'll have type 2s, but then we're going to have type 7s, right? We're going to have type 7s. That is going to be how we get this external information into the totally stub area. So let's go ahead and clear the screen here. And now we're going to come up, whoops, sorry, let me clear that there. We're going to come up to the HQ router. We're going to tear the adjacency down again, because as soon as I say Area 2, we're going to make it an NSSA. Now, it says it's already configured as a stub area. Do show run. Let me see if I have to take that off. Section OSPF. Is it going to force me to take it off? And it is. So we're going to say no Area 2, stub, no summary. And then we're going to say Area 2 NSSA. And do show run section OSPF. Oh, all right. No Area 2 stub. Where have we seen this behavior before? Where you remove the Area 2 stub no summary, and then it leaves the Area 2 stub in there. Exactly. When we said redistribute connected subnets, and then said no redistribute connected subnets, and then it just changed it to redistribute connected. So we have to say no Area 2 stub and get that off of there. And now we're going to say Area 2 NSSA. Now if we come down to the branch router, right, the adjacency is going to go down because, again, I'm a stub, so no Area 2 stub. I'm just a normal stub that was actually participating as a totally stub. But now we're going to say, now we're going to say Area 2 NSSA. And so now is an NSSA. Now I can have external information in the NSSA. But one very important thing we need to look at is when I say do show IP route OSPF, you'll notice what is not auto-magically injected. Exactly. There is no default route here anymore. So let's address that right now. What would I have to do? Exactly. I would have to send down a default route. I could statically configure a default route here, right? Or I can create a default route off of the HQ2 router. And let me see if I remember this. Area 2 NSSA default information originate, right? So I can say Area 2 NSSA, and since it doesn't auto-magically give me the default, because maybe that's not what I want, but in this case it is, because all we really need is the default route. So now when I come down to the branch 2 router and we say show IP route OSPF, look what we get. We pick up our ON2, and this is when we see the NSSA into metric type, right? So I get the ON2, and now I'm getting all of the type 3 information, okay, but I'm getting that default route as well. But this solves the bigger issue. And since we're talking about prefix lists and we're talking about route maps, let's go ahead and say do show IP interface brief, and let's build out this scenario a little bit. So I want to redistribute loopbacks 1, 2, 3, and 4. So those of all that, they look like /25s. Let's see if that's what they are here. Do show run. And yeah, 128, 128. Well, the first two are, and then the next two are 24. So here's what we're going to do. We'll work with loopbacks 1 and 2. And actually, since we can keep it all up, let's just do this. So I'm going to say IP prefix list. And now, let's get out to the context-sensitive help so we can talk it through. So I'm going to give it a name, IP prefix list. And we're going to give it a name, and I'm simply going to say external, we'll just leave it ext. So that's our name. Sequence number, I always like to start at 5, and then permit. So I'm going to permit 192.168, and permit means in this instance, or in this context, it means match. So 192.1, I'm sorry, we're going to get the 172s. 172.31. I'm going to make sure we get this right because I do not want to have to do this again. Dot 0. So that network, right, which is going to match the 64.1 slash 25, which includes 64.1. Then I'm going to come back and I'm going to say 64.128, but we need to change our sequence number, so we'll go up by 5, say 10. Now we're going to match these slash 24. So IP prefix list, external information, sequence 15, and I say permit, which in permit in this context means I'm matching the 172.31.65.0 slash 24. Make sure I got that right. Loop back 3, 172.31.65.0 slash 24. And then we're going to get the 127. Change the sequence number here. And this is what happens. If I try to enter the same sequence number in, you can see it says fail, sequence exists. So we want to make sure we change that sequence number. We come back here to 20. So let's see what we've got so far. Do show run include prefix. So there's my prefix list. The name of my prefix list is EXT. So now that we've matched all 4 networks for the 4 loopbacks, 1, 2, 3, and 4, now I'm going to go ahead and say route map, and we'll say into OSPF. We can put in here, we're going to permit 10, right? So this is my first statement. Now, permit and 10 are also the default. So I could say route map into OSPF. If you're going to type in permit 10, no big deal. You can certainly do it. But I can leave it off because permit and sequence number 10 are going to be my defaults right out of the gate. So what am I trying to do? I'm trying to match IP address. Now, be very careful here. And this is where most learners will find out the hard way that if I don't say prefix list, if I were to simply say match IP address, and this is where I'm putting the name of the prefix list, EXT, if I were to hit enter here, what is it matching? Is it matching my prefix list EXT? No, it is not. What it's matching is it's trying to find a match for an ACL with the name EXT, which is why when using the prefix lists, you should always, always, always remember to say match IP address prefix list EXT. So this route map in its first sequence is going to try to match anything in prefix list EXT, which is all the information we want. Now, I don't want anything else to come through. And so I leave it just the way it is because there's an explicit deny at the end of the route map. And since I only want to match those 4 networks, I'm done. So now we go back into router OSPF 1, right? And let's say do show run section OSPF. So we are in NSSA. We can see that, right? We see we're area 2, we're in NSSA. We weren't getting a default route because we didn't originate one. So now that we originate one, we are getting the default route, but we need to get this external information into the area 2 area so that other routers not in area 2, as the gateway router who is still pinging away here, right? Take a look. No reachability. We come down to the branch router here and we say redistribute connected subnets and then route map, and I put the name of my route map into OSPF. Now, what else can I do? I can tag that information as well to throw a special tag on there, and we'll say 867, whoops, sorry, I went backwards there, 8675309, my favorite tag, 8675309. All right. And now I hit enter. Do we get an error message here saying that this is a mismatch area type, you can't inject external information? No, we don't. You can totally see right now that the NSSA area type is the only area, the NSSA 2 area types, right? The totally stub NSSA and then the NSSA. Those are the only 2 OSPF area types that are going to allow me to inject external information into them. But now we've got that information in there. So let's go ahead and say do show IP OSPF database. And let's get that OSPF database. Because take a look at the external information that we now have. And it comes into the NSSA not as a type 5, and it doesn't come in as a type 5 because it needs to be able to differentiate between the normal OSPF area external information that has been introduced and the NSSA stub area type information that's being brought in here. And that's why we see it as a type 7. We still see all of those type 3s, right? We see the type 1s, we see the type 2 for the DR, but here's all that information we've just introduced in, our type 7 information. So let's clear that out, and let's see on the gateway. Whoa, take a look at that. The gateway router is rocking and rolling because now it does have reachability. If I were to say show IP route, and actually let's trim it down to show IP route OSPF. It does have reachability information to all of those networks. And where is the translation taking place? It's taking place at the ABR, who is HQ2. Because remember, what do we see these as? We don't see these as N2s. And there is your default seed metric, even for the NSSAs, that type 7s that come in as type 5s. That default seed metric is still going to be 20 unless we do something about it. And so let's build off of that first activity. Let's build on that now, and let's go ahead and change our redistribution statement here, which remember was redistribute connected subnets route map. We're tagging the routing information, and now I'm even going to go so far as to say metric type. And what is the metric type? We're going to make it type 1. Now let's make sure, do show run section OSPF, because OSPF is very peculiar. So take a look at that. I'm redistributing that information in. So again, how do I read this in English? I'm redistributing from connected interfaces into OSPF process ID 1, and when I redistribute those connected networks in, they're going to be metric type 1. So because we're an SSA, it's going to be an N1. We're going to grab all the subnets to ensure that we get classless information. I'm going to tag it with a tag so that I can identify it later and maybe manipulate it later inside other OSPF areas with 8675309, and I'm applying the route map into OSPF on this redistribution statement. And that was saying that it's going to look at those prefix lists that we created, and it's going to apply those so that I only get those 4 172.31 networks. So now when the seed metric was 20, we know what that looks like. Let's come back onto the gateway router here. Let's rerun that command. Now, what does it look like for my OE1s? Exactly. It's not 20. Now it's 41. And this is the interesting part, right? So we come back to the gateway router. How many ways can the gateway router reach those networks down here? Yeah, see, now it does make a difference, because the gateway router could come down this way, and this is by far the #1 way that we want to go, because we can see we go right to HQ and then down to the branch and out to the external networks. So here, the internal cost of these other links matters, because I've got more than one way to get there. So this is the most optimal way to get down there. Let's change the pen color here real quick to blue. Gateway router could also go like this to get down there. And that is by far not the best way. That is the #2 way to get there, or I say the #2. And this would be suboptimal. So, and the reason I continued the conversation once the challenge had ended is because this is a classic example of hot potato versus cold potato, where we can clearly see that the optimal way to go, and when we want the cost of these internal links added in to the metric calculation for this external routing information, is right here. We want it coming this way. We don't want to send it in there with the seed metric of 20 saying, I don't care what the cost of that link is, or this link, or that link, or this link. I want to know. So we're going to make it metric type 1 to make sure that these internal links are accounted for and get added into the cost of the default seed metric of 20 to make sure that Gateway can make the optimal hot potato. Here's my hot potato decision right here, right? Potato. I don't know why I have a problem spelling that, but I do. Hot potato. We want to make sure that Gateway says, yeah, we are going directly to the ABR, and then we're going directly down to the branch to get to those external networks. We don't want the Gateway router to say, oh, well, I'm going to come over to HQ1, then I'm going to come down to distribution, then I'm going to go up to HQ2, then I'm going to come down to the branch, and then I'm going to get to those external networks. That is suboptimal. And it's suboptimal because from Gateway's perspective, we've got the seed metric of 20. That would be 10. That would be 10. That would be 10 added onto the metric. That would be 10. And then the cost of the loopback, which I believe is 1. So going this way, it's going to be 20 plus 10, 30, 40, 50, 60, 61 would be our cost. Coming the optimal way, the hot potato way, right? Remember, don't get burned by going suboptimal. Move that hot potato out of your hands as quick as you can. We've got a cost of 20 plus 10 is 30, plus that is 40, plus 1 is 41. And that is the difference between hot potato and cold potato routing. Don't get caught with the hot potato and get burned with suboptimal routing at a cost of 61. Go that hot potato path, take into account the internal costs of all of the links, and get it for a cost of 40. And let's confirm that. Is that what we were seeing? And I'm pretty sure that was what we were seeing. Yeah, 41. There's your cost. So how do I know that the cost is 61 going the opposite way? Well, if we come to the diagram here, if I shut down Ethernet 00 on HQ2, which takes 2 seconds to do here, and let's get into global config interface Ethernet 00 shut. So let's shut that down. So OSPF does a full SPF run. We've had a transit link go down. Type 1, type LSAs are changing here, right? We come back to the gateway router. We run the exact same command. And the adjacency, show IP OSPF interface brief. Do we still have that adjacency? And we should see, we're still seeing those type 1s as 41. And give me a second here. Why is it still 41 when Ethernet 00 is down? It should now be 20, 30, 40, 50, 61. And am I not waiting long enough here? Hold on a second. Let's make, oh, there we go. Yeah, the adjacency hadn't gone down, so I was black holing the traffic up until that point. But we should see, and let's make sure we're seeing it here off the branch, the HQ2 router should still be seen. Do show IP route OSPF. Yeah, so it's still seeing those ON1s here, which get translated to type 5s. So let's follow the path. Maybe it's just a timing issue here. Down to the distribution router, do, oops, sorry, show IP route OSPF. Okay, so there my E1s are back. They're still showing that cost of 41 though, and let's back out. From here it's 41, right? From here it's 41. So it's a different 41. Even I apologize, I said still 41. Because I'm sorry, let's make sure we get this right. The default seed metric is going to be 20. So it's 20 plus the outgoing interfaces. So 10, 20, 21, and the default seed metric of 20 makes 41. So now when I come to HQ, HQ should see it as 51, and the gateway should see it as 61. And it looks like we were just moving a little faster than OSPF and the simulator was moving. So 41 on the distribution. HQ1, if HQ1 would come back. And hold on one second here. All right, sorry about that interruption there. So again, here on HQ1, we should see show IP route OSPF, and we don't see that information even though, because we're not stubs here though. Hold on one second. Show run section OSPF. So we're not a stub. Why are we not getting that type 5 information? So the type 5 should go in here, and HQ should pick up that type 5 information. Unless it's getting it, it's getting it from, so fortuitous failure is what I like to call this. So trying to describe for you the cost changing to 61, that's not going to happen. So we're going to see it here. We're going to see the cost here, and we see it bump to 41, right? And that works because this is the ABR. It's sending that information down. That was injected here as a type 7. However, but wait a second, we shut that link down. So HQ should see it. I was going to say it wouldn't get it because the OE1, no. So we should see, HQ should see that information. So the question now becomes, why in area 1 did the information make it to the dist but not to the HQ router? And so I'm going to spend a couple seconds here. Let's try to wrap this up. And that adjacency is up on the HQ router. Passive interface default. Is there a reason I passived? Yeah, so we did interface default. So let's say here, let's say show IP OSPF interfaces. So in area 2, where are we at here? Let's go back up here. Ethernet 1 is up, and the router ID is, am I on the right router? HQ1, yeah, HQ1 is the router we should be on. Let's make sure we're not looking by something here. Priority is 1, and that is correct. And let me get, sorry, I got to pull the job aid back up here, keep looking at it. So everything HQ1 should have a single interface, Ethernet 0.1 in area 1. HQ1, Ethernet 0.1 in area 1. And that's right, it's in area 1. And Ethernet 0.0 should be in area 0. And that interface, did I bring it back up? No, okay, I'm sorry. Yeah, that interface is going to stay up because that's not the interface we shut down. So now we've got area 1 here attached, and we are good. So we should see show IP OSPF neighbor. Whoops. So we see that was the distribution router. Remember, that was our gateway, and that's correct. And that was the distribution router. So we've got the adjacency there. Show IP OSPF database. So it's time for some troubleshooting here for area 1, type 5 LSAs. And I see them here. Show IP route OSPF. But I'm not seeing them. So I've got the LSA, but they're not showing up in the routing table. And it's got to be something that I'm looking by here. Why are those not showing up? Because they should show up as type 5 LSAs, and they are not. So let's do this. Clear IP OSPF proc. All right, let's clear the OSPF process. All right, the adjacencies come back up. For 9, we needed to come back up for the distribution router, which is in area 1 along with it. Show IP OSPF neighbors. All right, so it's in the two-way state. Two-way druther. Okay, good. So then show IP route OSPF. Two-way, and it's a broadcast segment, so that should be... Why is that not coming up there? Whoops, sorry. Yeah, this is an Ethernet segment. So dist is not being participating in the DR-BDR election, so HQ1 or 2 should become the... Oh, there we go, the DR. Okay, it's taken a lot longer than I had thought there. It's making me think that something's not right. So show IP route OSPF, and we still don't see that information. And let's say show IP OSPF neighbor. Is it because DR other? So who's the DR? If HQ1, it's just druther. So why is there not... So it's interesting here, right? Because it's a broadcast segment. It's not participating in the DR-BDR election. So if there's a disconnect here for any reason, HQ2 should have been elected as the DR. Or one of HQ1 or HQ2 should be elected. Do show IP OSPF neighbor. And so they're all druthers. There is no election taking place. And so here's what I believe is happening, and we're going to sort this out right now. So since distribution is not participating in the DR-BDR election, we've cut this link off here between HQ1 and HQ2. So there is no DR, which means that that information, those type 5 LSAs, are going to get sent down from HQ2 to distribution. And this is definitely an unforeseen side effect of what I did. So here's what we're going to do. We're going to change on the distribution router. We're going to go into interface Ethernet, was it 00? I do show IP interface brief. And we're going to turn on that DR-BDR election, interface Ethernet 00. And we're going to say no IP OSPF priority 0. We're going to get an Ethernet 01, no IP OSPF priority. Because we cut that link between HQ1 and HQ2, and then we're going to say do clear IP OSPF, do clear IP OSPF proc. Yes. So what I'm going to try to do now is I'm going to try to force a DR-BDR election here in area 1. So do show IP OSPF neighbors. There we go. Okay. Excuse me. So now that there's the DR, let's see, does that sort things out? And we'll come over here to, we want to come up to the HQ router who should be seeing that information. So good, now it sees it as the BDR, right? And it sees the gateway router as the DR, but now when I say show IP OSPF route, or show IP route OSPF, we are not getting that information still. Why are we not picking that information up? And I thought that that would solve the problem, because that type 5 information should get propagated throughout area 1. So we're going to stop here. I would have to take a look to see if this is something maybe specific here, or if I'm just overlooking a subtlety in OSPF. But the distribution router does see that information, do show IP route OSPF, and it sees it with that cost of 41. But we should, from HQ1's perspective, we should see that information in the routing table as type 5 LSAs, but we are not for some reason. And let me bring back the link here. Bring that link back up And what we're going to see is it does get passed along to HQ1 like it was originally. And we'll give it a second here. Yeah, I thought it had something to do with the DR BDR, and maybe that was it. And yeah, you can see, because now we pick the information up from router HQ2. All right, I'd have to give some extra look at that, give some extra attention to that. But anyway, let's go ahead and wrap things up here with challenge activity number 5, which was configuring OSPF. And we talked about a lot of stuff in this tutorial because, again, the topology presented opportunities to expand the conversation. All right, thanks so much for watching, and I will see you guys at 6 o'clock.